Geometro Ninjas, and today we're going to continue our discussion on quadrilaterals. Today we're going to talk about trapezoids and kites. So we have two types of trapezoids. Our first is a non-isosceles trapezoid. So unlike our parallelograms, trapezoids only have one pair of parallel sides. Now, following our same side interior rule that we learned way back in Unit 2, these angles that are between our parallel lines are going to continue to be supplementary. So if we were to add these two angles together, their sum would equal 180 degrees because those are still two parallel lines being cut by a single transversal. So that follows that same rule. Our second type of trapezoid is an isosceles trapezoid. Now we've seen this word isosceles before. We saw it on a triangle. And when we saw it in a triangle, we knew that an isosceles triangle was a triangle where two legs were congruent. We created congruent base angles and all that good stuff. Isosceles trapezoid does the same thing. Okay, we still have the one pair of parallel sides and consecutive angles are congruent, but now because it's isosceles, the legs, the ones that are not parallel sides, are going to be congruent, which in turn makes our diagonals congruent, making our base angles congruent. And now the opposite angles are supplementary because they are congruent to the same angles. That's that congruent supplement theorem that we love and know so much. So let's go ahead and put a couple of these properties into play. So the first thing for number one, we see this is a non-isosceles trapezoid because our legs do not have congruent tick marks. So what we're going to do is we're going to take J and M. We know that these are between parallel lines, so they have to be supplementary. So to find the measure of angle M, we are simply doing 180 minus 87. And we end up with 93. And then we're going to do the same thing for angle K because between our parallel lines, those angles need to be supplementary. 180 minus 51. Angle K is 129. So notice, unlike our parallelograms, these angles are no longer congruent. If you see the same thing is true, those are no longer congruent. So the opposite angles are not congruent in a non-isosceles triangle, or trapezoid, excuse me, and the same thing is true for an isosceles trapezoid. We can use that same rule and throw a little bit of algebra in there on you. So we've got our parallel lines cut by a singular transversal. You guys know what that rule is. Those two angles are supplementary. So we're going to add them together, set it equal to 180. Combine like terms. Subtract 60 from both sides. 8x is 120. And then we divide by the coefficient 8, so we get x is 15. So when we're using our supplementary relationship, two angles add together to be 180. Now let's move on to some isosceles trapezoids. So they're telling us, hey, this is isosceles trapezoid. Remember, things are congruent, numbers are equal. So if we see a congruent sign, it wants to know which segment is congruent to that. So DG is our first segment, so that is the left leg, so congruent to it is EF, our right leg, and then DF is one of our diagonals. And because it's an isosceles trapezoid, our other diagonals are congruent. Now we can actually do the same thing we did above. Consecutive angles are supplementary. So 180 minus 112. Is going to give us S is 68. But because, now remember, isosceles, our base angles are congruent. So once we find the left side of our trapezoid, we automatically know the right side of our trapezoid. It's kind of neat, huh? So 112, let me see if I can write that in there real quick. You know, writing is a struggle sometimes. And then both of the other ones are 68 degrees. So it's big. Our top base angles, because these are still a base, is congruent. Our bottom base angles are congruent. Consecutive angles are supplementary. Consecutive angles are supplementary. And now, because it's isosceles, our opposite angles are also supplementary. The next thing we're going to talk about in a trapezoid is the mid-segment of a trapezoid. You guys have seen this word before, mid-segment. And the mid-segment of a trapezoid connects the midpoint of two legs. So if it's going to be the mid-segment, sorry, we time traveled there a little bit, all three of these lines need to be parallel. So AB, EF, and DC need to be parallel to one another. Because if EF isn't parallel, it's not connecting the midpoints of each one. And to find the length of that mid-segment, it is our mid-segment, in this case is EF, equals base 1, AB, plus base 2, DC, divided by 2. So all we're doing is taking the average of those two numbers. So if we wanted to just write a basic formula that always works every time we see it, it is mid-segment is equal to base 1 plus base 2 divided by 2. Let's put that into action. They said, hey, the trapezoid above, answer the question. So they said AB is 14. So we're just going to cheat a little bit. We're going to come back up here. 14. DC is 26. Find the length of our mid-segment. So EF is half the sum of our two bases. So 14 plus 26 is 40. And then 40 divided by 2 is 20. They can also, I'm going to erase these lines so we can reuse this same diagram so we don't have to try to come up with something new. Okay. We can also be given the mid-segment and reverse engineer to find one of our bases. So on number 3, they tell us that EF is 22 and DC is 38. So now we know the length of our mid-segment, but we do not know the length of our base, our top base. So now it's 22 equals the first base we know, 38, plus AB, which is the base we don't know, divided by 2. I know you guys love fractions, so let's get rid of that, guys. We're going to multiply both sides by 2 to clear that denominator on the right. Thanks for playing. So we get 44. Let's see if I can get back to the right color. Pen didn't switch on me. 44 equals AB plus 38. One final step is we're going to subtract 38 from both sides. So we find the length of AB to be 6. And of course, it wouldn't be geometry class without sprinkling some algebra on top. We can do the same thing given algebraic properties. So we get 5x minus 19 equals 38 plus x plus 14 over 2. Now, if you want to clear the denominator like we did on the last one from the jump, you can. However, combine like terms on that right side first. If those two numbers are even, why not just keep them? But since one of them is not, let's go ahead and clear that fraction. So multiply both sides by 2. Doing that cancels the denominator on the right. Now notice we're not distributing the 2 to the top of that one. We are going to distribute our 2 over here, though, into both terms. We're not just multiplying 5 by 2, we're multiplying 5x minus 19 times 2. So we get 10x minus 38, and that's a common mistake I see when we're doing this. And we're going to isolate our variable to one side, so subtract 10x. 9x minus 38 is equal to 52. I'm going to skedaddle up here so we can create a little bit more room. Just going to rewrite it out. 9x minus 38 is 52. We're going to add 38 to both sides, which of course makes 9x equal to 90. Divide by 9, so x is 10. The problem wanted us to find the length of YZ. So we're going to take that value we found and substitute it in for the original expression. 5 times 10 minus 19, which of course is 31. All right, and our final piece of quadrilateral that we're learning for this unit is a kite. A kite is a quadrilateral that has no parallel sides. Now, we do have two pairs of congruent consecutive sides, so you'll have short sides and long sides. That's the way we'll refer to it in the video. Our one singular pair of opposite angles are congruent, and it's with the short side. So if you look at this, it says ABC to ADC. Those are your congruence pieces right there. Okay, it's always going to be on your short side. And then your diagonals are perpendicular, meaning they intersect at 90 degrees. Okay, so we look at this first one. It just gives us the top length and the bottom angle. But if you think back to our rule, one pair of opposite angles are congruent. Well, those aren't congruent, so it has to be the other pair. So we're just going to let the same variable represent both. Because it's a quadrilateral, we know the interior angle sum is 360 degrees. So all we're going to do is we're going to add all four of these angles together and set it equal to 360. All right, so you get 2x and then 85 plus 43. Pardon my delay. I had to find a calculator since my answer key would not show me that math. How dare they? 85 plus 43, of course, being 128. We're going to subtract 128 from both sides. So 360 minus 128 is 232. And then divide both sides by 2. So x is 116, which is what the answer key says. So we must have done something right. And because they're congruent, we know that each angle is going to be 116. All right, now the cool thing about kites is it's going to cut it into two congruent triangles. So if this triangle, remember they're perpendicular, so now we have a right triangle here, is going to be congruent to the right side, even though my picture is not very congruent. And then the bottom one is also going to create congruent triangles. You got the reflexive property in the middle, making that side congruent to one another. And then, of course, you have your two legs, making that congruent in a kite. So if you have 37, to find this missing angle, you can just use the fact that it's got to be complementary to one another. So 90 minus 37, and PQT is 53. PTQ, so P, follow, we started our, go to our vertex and up. We know that one is 90. And then QRT, because our triangles are congruent, we know that if PQ is 37, QRT has to be 37. Right. Now they're going to hit us with all of them. Right off the bat, we know 3 is 90 because we know that in a kite, the diagonals are perpendicular. So we can take care of that real quick. So we can go also know that this angle is going to be congruent because of that isosceles relationship. Boom, 65. Look at that. We're already an eighth of the way there. So 4 is 65. Same thing is true about this one. If one side of that triangle is 52, guess what? The other side of that triangle is going to be 52. So that guy's 52. Now we either need to find 5 or 6, and then 1 or 2, because then that'll give us the other ones. Remember, they're complementary to one another. So 90 minus 52, of course, is 38. So 5 is 38. And if 5 is 38, 6 is 38. 38, 38. And then our final angle, 1 and 2. Why did I write 252? I'm goofball. Sorry about that, guys. 7 was 52. We fixed that. I think I said 2, wrote 2. It happens. Down here, we know 1 and 65 are complementary, so we do 90 minus 65, and we find 25. And if 1 is 25, 2 is 25, because those are congruent triangles. Right? Let's do a little bit of side work here now. Okay, they told us WX is 14, WR is 8. They want us to find RZ. Okay, so they want us to find RZ. Well, we know our triangles are congruent, so if RZ is X, we can just move it up here, or we could have moved the 14 down, it's up to you. But if you notice, this forms a right triangle, and if we know 2 out of 3 sides of a right triangle, you guessed it, we're rolling with our homie Pythagoras. So 8 squared plus x squared equals 14 squared. Leg squared plus leg squared equals hypotenuse squared. We know 14 is the hypotenuse because it's opposite of our 90. So 64 plus x squared equals 196. Subtract 64 from both sides. X squared is 132. Once we isolate our variable, now we can square root both sides. So x, which is RZ, is 11.5. Guys, that concludes our lesson for today on trapezoids and kites. Remember, Coach Oliver believes I can understand today's lesson. I am capable of understanding math. Today's lesson might be challenging, but I am up for the challenge. I expect to make mistakes today and learn from those mistakes. And finally, the best one of them all, math is beautiful when I see how it all fits together. Thank you guys for your attention. Go be great today.